Hi everyone, my name is Ken, and for today's session, we're going to discuss the VeloCloud sd-wan design and best practice. So here's the agenda for this session, and first we're going to focus on the VeloCloud Edge insertion and design. And basically, the VeloCloud Edge is the data plane component of the solution, and it's typically placed at customer branches or in the data center. Then we're going to discuss the design options for high availability. So that include the native VeloCloud HA, VRP insertion, clustering of the VeloCloud Edge in the data center. And then after that, for the very last part, we're going to discuss security integration with VeloCloud SD-WAN and how to actually secure internet traffic. So first, this slide is a high-level architecture of the various insertion options for the VeloCloud Edge. So on the right here, we have the VeloCloud Edge configured as a hub cluster in the data center. So it sits, sort of behind the firewall, and then also connected to the core switch, so that it can establish overlay tunnels, or it can sit there and wait for overlay tunnels from both internet and MPLS. The blue icons represent the CE router devices, and then the white icon with a cloud logo basically represent the VeloCloud edges. And so on the left here, we have various branch insertion topologies, and then the VeloCloud gateway, which is actually the control plane component, actually sits on the internet, right, for our hosted solution. So that's where you have an option of building overlay tunnels from the branch towards the VeloCloud gateway, so that you can optimize, SaaS application going to the internet. So let's look at the various insertion options for the branch. So first, there's the VRP branch, where the edge is running VRP with the CE router, and so basically, when the edge is the VRP master, it's actually establishing overlay tunnels across both MPLS and internet, and it's the default gateway for the local LAN. And if it goes down, then traffic would simply follow the CE router, because then the CE would become the VRP master. On the second topology here is where the VeloCloud Edge is inserted off path and is running routing protocols with the downstream L2E switch, so that it can attract traffic going to remote sites towards the VeloCloud Edge instead of following the CE router. So in that case, it's off path in the sense that if it goes down, it would not have impact to the branch, and we're simply using routing protocol or maybe floating static routes to redirect traffic from the L3 switch to the VeloCloud Edge. And again, in this hybrid insertion topology, we're actually establishing overlay tunnel across both MPLS and the internet. Third one is insertion of the VeloCloud Edge to replace a CE device. So it's connected directly to the PE to MPLS, and then also connected to internet. And that can be behind a NAT. And all of my connectivity I've drawn on this slide here are basically logical connections. And then at last, there is the VeloCloud Edge that is inserted at branches that has internet only. So in this case, traffic from the internet only site, right, would have to go through the data center hub to reach other SD-WAN sites, unless you have dynamic branch-to-branch enabled. And when you do that, then there will be tunnels directly from that branch towards towards other sites' internet circuit. And then for completeness, there's also a non-VeloCloud site that is a hybrid site that uses MPLS. Unless it goes down, then it would use VPN, for example, DMVPN to connect to other sites. And so this is just a high level, and we're going to go into the details for the various insertion options. So first, we're going to discuss the two insertion options. One is where the VC, where VeloCloud Edge is in path, and then the second is where it's off path. So for the in path option, basically the edge will become the default gateway for the local LAN or local VLANs, and if there are multiple subnets downstream on the L2 or L3 switch, you would just make the interface a trunk between the edge and the downstream L2 or L3 switch. And then the edge would hand out IP addressing via DHCP, and it would also be the default gateway. And in this case, the edge would establish overlay tunnels across both MPLS and internet. So that's what the green lines in the drawing represent, are basically the overlay tunnels. This is consistent throughout the slides. And so I would recommend proposing HA in this option, because if the VeloCloud Edge goes down, then you will experience an outage for this in this insertion topology. On the right is where the VeloCloud Edge is placed off path, and the L3 switch remains the default gateway for the local LAN. So traffic generally without the edge will go to the layer 3 switch, which is the default gateway for the local VLANs. Then it would go to the CE device. When you insert the VeloCloud Edge, what happens is we would usually run routing protocol between the L3 switch and the VeloCloud Edge, so that the edge can redistribute routes it learns from the sd-wan fabric into the routing protocol, and basically redirect traffic from the L3 switch towards the edge. And we can achieve that by either injecting more specific prefixes or by having a more favorable admin distance or routing metric. So one common topology or insertion is where we run BGP between the VeloCloud Edge and the L3 switch, and then we simply inject the routes from SD-WAN to BGP with a shorter AS path, for example, so that traffic will prefer the VeloCloud Edge over the traditional MPLS path. Again, in this topology, we're actually establishing overlay tunnels to both internet and to MPLS, and the tunnel across MPLS actually goes through the L3 switch and the CE router. And if the edge goes down, then traffic will simply follow the normal path right across the CE and MPLS. Okay, so very quickly for hybrid sites, there's really 3 connectivity options to the PE. And so one is where the first one on the left is where we do not run any routing protocol between the edge and the PE, and we're simply using MPLS as a transport to establish the tunnels. So basically the MPLS provider in this case would never see the actual end user traffic inside of the tunnel, and neither do they need to advertise the branch prefixes. So in this case, all the MPLS needs to know is how to route between the tunnel source IPs at the branch and the tunnel source IPs in the data center and other SD-WAN sites. And so all traffic going site to site would be encapsulated within the tunnels across both MPLS and the internet, and the MPLS provider would never actually see that traffic. So this is simple, and really no CE is needed. And then, but the downside is that all traffic going from this branch would have to traverse the hub, right, to reach other SD-WAN sites or to reach the traditional MPLS sites. But it's very simple and straightforward and typically recommended if you don't have a lot of traffic between a SD-WAN hybrid site and non-SD-WAN branch, MPLS sites. Topology on the right is probably the most common, is where the VeloCloud Edge runs BGP with the PE device, learns all of the routes from MPLS, including the non-VeloCloud site, right, traditional MPLS prefixes. And this would allow traffic from the local branch with this insertion topology to talk to the traditional MPLS sites directly, through the underlay. And so not all traffic are encapsulated within the overlay tunnel. And we built a feature called an uplink feature to mark the BGP uplink neighbor as or BGP neighbor as an uplink, so that we do not redistribute routes learned from MPLS into the overlay, and we also don't redistribute routes we learn from SD-WAN into BGP, into this BGP session here, which we marked as uplink. And so that's there to prevent the branch from becoming a transit. So imagine if this is a branch site, you learn certain prefixes, let's say the traditional non-SD-WAN prefixes for MPLS, and then if you redistribute that into the SD-WAN fabric, then you're risking this branch site becoming a transit for other sites that also needs to reach that MPLS prefix that it learns from BGP. And so that's what the uplink feature will do, is basically disable mutual redistribution between BGP, the underlay routing protocol, and the SD-WAN overlay fabric. The option in the middle here is only recommended for data center sites. And we don't recommend this at branch site. And the reason is that there is not a feature in OSPF that is similar to the uplink feature. So we don't have that feature in OSPF, and there isn't a very easy way to tag OSPF routes. Unlike BGP, you can use communities, so it's harder to block traffic redistribution between OSPF and SD-WAN routes. And so, if you automatically enable mutual redistribution between OSPF on this edge to the SD-WAN fabric, then there's a possibility that this branch site might become a transit. So this is only recommended at data center locations. So as a summary, to this, with both insertion and also PE connectivity, there's really, two different topologies. One is in-path, one is off-path, where for off-path, basically you have to run routing protocol to attract routes towards the VeloCloud edge. And so it's less intrusive, but again, a little more difficult to actually insert the VeloCloud edge. In the in-path option, the VeloCloud edge is the default gateway. It's also the DHCP server. So it's a bit easier in terms of insertion. And you have a choice of either running in both of these. Actually, only in this in-path option, you have a choice of either running routing protocol or not with the CE device, right? If you don't run routing protocol, then MPLS would just simply become a transit for the overlay tunnel. Okay, so next we're going to discuss the data center insertion options. And what it comes down to is that in the data center, typically you don't want to you don't want to insert the edge and cause the customer to make any infrastructure changes, right? So we want to be as non-disruptive as possible, and make it an easy enough an insertion where they don't have to make too many changes on the firewall. So with that in mind, there's really two options, and we generally recommend the option on the left here. And so this is where there are at least two arms configured on the VeloCloud edge or hub device that is placed in a data center. And so it needs to establish at least two different overlays, right? One across internet and one across MPLS. So basically what we would do is we would place one WAN interface of the edge in the DMZ, so that it can sit there and wait for tunnel initiation from other branch devices. And then the second arm of the VeloCloud hub edge would connect to the trusted interface of the firewall, or it can be connected directly to the core switch. And that arm is used for basically routing to the local data center prefixes, as well as used for establishing overlay tunnel across MPLS. And so if you look at this, even if the customer has multiple internet circuits, you would just simply create sub-interfaces on that first arm in the DMZ, and then basically use policy-based routing, PBR, to map the sub-interface towards that specific ISP circuit. So this, this is probably the easiest insertion option. The only additional configuration other than one-on-one NAT, where the DMZ configuration is basically a new subnet or transit VLAN between the hub and the firewall, if you connect it to the firewall. So, and you would then have to advertise that transit subnet into MPLS, right? So that the remote branch sites can establish overlay to the hub through MPLS. The second option on the right here simply just highlight the fact that you can actually establish multiple overlay tunnels on a single interface with different next hop IP addresses. So imagine that on the shared VLAN, basically a shared segment, the firewall is .1, the CE is .2, and let's just say the edge is .10. And so what you can do in this case is you can actually create at least two different overlay tunnels with the internet overlay tunnel with the next hop of the firewall being .1, and then a separate MPLS overlay tunnel with the next hop being the CE, with the .2 IP. And so this is usually actually not recommended because generally for ease of configuration, you want to separate the interfaces going towards MPLS versus going to the internet. But this is just to highlight the fact that you can actually create two different overlay tunnels on the same interface. Okay, so now we're going to have a few slides that discuss the placement of the VeloCloud edge when there's already a firewall in place. And really the main concern here is how do you allow full visibility on the firewall for internet bound traffic, coming from the VeloCloud edge. And so remember that our gateways, the VeloCloud gateway, which is control plane, typically sits on the internet, and it's also there so that it can serve as a tunnel end, right? Essentially almost like a conduit to the internet for certain SaaS applications that you want to optimize. And so in this case, if you place on the left-hand side, if you place a VeloCloud edge behind the firewall, and we send traffic from the VeloCloud edge to the VeloCloud gateway, and we encapsulate SaaS applications within that tunnel, then the firewall will see, will not be able to see the actual end user traffic. It will just simply see the overlay tunnel traffic, which is UDP 2426. And so if the requirement is for the firewall to see all of the traffic from the local VLANs, then basically you would have to offload internet traffic on the VCE towards the firewall and then send it clear, right, without sending it through the tunnel. So you can achieve that by using business policy to send internet traffic direct. And then in this case, there will be no NATing on the firewall for the WAN interface going towards internet, and the firewall will be responsible for both NAT and PAT. On the right side is where the VeloCloud edge is actually placed in front of the firewall. So in this case, any traffic that actually comes to the VeloCloud edge has already been inspected and filtered by the firewall. And the firewall would have full visibility into all of the local LAN traffic. But the VeloCloud edge will be responsible for NATing the traffic that goes underlay to the internet, or traffic that is not put into the overlay tunnel to the internet. So the downside of this topology is obviously that if you need to establish overlay across MPLS, then the tunnel across MPLS from the VeloCloud edge would have to go back through the firewall, right, to actually build that overlay tunnel. So this is usually not recommended for hybrid sites, and because customers typically don't like that. But this is very easy if it's a internet-only site that might have multiple internet circuits. Then it's not really a concern, right? Because a customer would not need to open up the firewall port to allow the tunnel across MPLS. Okay, just to walk through the few examples. So on the left here is a typical branch with the LAN, a router that is also routes towards MPLS, and then also it's behind a firewall. So if you replace the branch router with the VeloCloud edge behind the firewall, then what happens is the tunnel towards the internet side will be established through the firewall. So any optimized SaaS traffic that you want to send from the VeloCloud edge to the VeloCloud gateway would then be tunneled right through the firewall. So if there is requirement, right, for the firewall to filter all traffic including internet, then you would not be able to optimize the SaaS traffic to the gateway. You would simply just have to offload internet traffic towards the firewall. On the second example here, this is where we would basically insert the VeloCloud edge at the branch, very similar to what we discussed earlier for the data center. So you have one arm in the DMZ, second arm in the trusted zone for routing towards the local LAN, also for establishing overlay across the MPLS. So in this case, again, almost no changes on the firewall needed. So if they have any existing, NAT rules or zoning on the firewall, then this is really a recommended option on the branch as well. And the last one is where the VeloCloud edge is actually placed in front of the firewall. And again, the overlay over MPLS in this case would have to be established over the same route interface, toward the firewall. So you would disable NAT on the firewall and just make the connection between the firewall and the edge a router interface. And in this case, you can go ahead and optimize SaaS traffic, optimize certain SaaS traffic you want to send towards the firewall, because by the time the traffic the SaaS traffic reach the edge, it has already been filtered and approved by the firewall. So next, we're going to discuss certain best practice that VeloCloud or VeloCloud recommend. So first is for DCI. So if there is a fast convergence and high bandwidth DCI between data centers, what we recommend is not to run overlay tunnel across the DCI, because there's extra overhead for SD-WAN. And also if there is storage backup between data centers, they can have a fairly high MTU, right, for that traffic, and you don't want to fragment that across the overlay tunnel. So from a configuration standpoint, what's needed is that you would need a unique network profile for the specific data center hubs. So in this case, you can see, all we have to do is create unique hub profile for the two data centers, and then for Cloud VPN, we will simply not choose either. We do not check either branch to VeloCloud hubs or the branch-to-branch VPN. So in that case, there will be no overlay tunnels established between data center 1 hub and the data center 2 hub. For the branch, it's the same. You can basically choose the two data center hubs, in this case, the two data center clusters in order, and prefer data center 1 over data center 2. In terms of inserting VeloCloud Edge with WAN optimization, the recommendation is basically make sure that the WAN optimization device, such as Riverbed, is actually downstream from the edge, and then you enable either port transparency mode or full transparency mode on the Riverbed steelheads. And for those Riverbed steelheads, the default mode is actually what they call correct addressing mode, and it's almost like a NAT mode. So basically, all traffic between the steelheads are encapsulated within their own tunnel, and so that has to be changed to port transparency or full transparency mode if you want to integrate SD-WAN or VeloCloud SD-WAN. The reason is only in port transparency or full transparency mode will we be able to use our application recognition engine, or DPI, to actually recognize the optimized traffic and then steer them correctly. And that's also the way we do QoS, is based on applications and service and the service class, and not just on priority. And this does not impact traffic that is not optimized by the steelhead. So again, if you have a WAN optimization device such as Riverbed, you want to make sure that the IP address and the ports of the actual application traffic is exposed to the VeloCloud Edge. So next, we're going to discuss high availability. And first, we're going to talk about the VeloCloud native HA. But here's the actual 3 options that are available right now. First is the native VeloCloud HA on the left here. Then there's the VRP insertion option, and then the new enhanced active HA that is now available since release 2.5. So on the left here is the original VeloCloud native HA, where basically the standby edge is a mirror image of the active edge, And when an edge is on standby, basically it blocks all of the WAN and LAN ports, and it blocks pretty much all the ports except for the interface that is used to connect to the primary edge for HA. And that interface is generally LAN 1 for the 840s, for the 520s and 540s, the smaller branch edge devices. And on the larger boxes, such as the 840 and the 2000, the HA interface is gig E1. So in this case, each edge will be connected to all of the transports available. And if you look at this, we basically require a layer 2 switch, if you will, right, on the WAN side, because both of the edges would need to be connected exactly the same. So during failover, actually this is probably the fastest failover unless you have routing protocol running on the LAN side, and it can fail over from the active to the standby, within 400 milliseconds, and not impact the actual user traffic, unless there's routing on the LAN side. Then the convergence would be whichever that's the slowest, right, between the routing protocols on the LAN side. The option in the middle is where we run VRP between the CE router and the VeloCloud edge. So basically on the VeloCloud edge, we established 2 tunnels in this hybrid site across both internet and MPLS. And then we are the VRP master when we are alive. And then if the VeloCloud edge goes down, then VRP master would be the CE device. And then on the last one is where we eliminate the L2 switch requirement on the WAN side, and basically the active edge would establish an overlay through the standby edge device. Note that even for the enhanced HA option, traffic, from a flow perspective, still do not flow across both edges, right? All of the active flows are actually on the active edge. And we're simply just using the standby edge to establish the second overlay. Okay, so very quickly, this is how the native HA works. So by default, there is a link between the edge devices, and then the standby edge will block all of its ports. And once they establish states between each other, then basically the failover link will be used to communicate their state information, used for heart beating and also for syncing the flows. And then there will be a virtual MAC address created, right, for each of these interfaces, so that when the active goes down and the standby comes up, the standby would then send gratuitous ARPs all of its interfaces, right, to update the downstream devices and the upstream devices about the moving of the virtual MAC. Okay, and so as we discussed earlier, for the native HA, we basically require a L2 device on the WAN side, so that both of the edges can be connected exactly the same way. And so standby would be a mirror image of the active. From a configuration standpoint, in the VeloCloud orchestrator or the VCO, only one edge needs to be provisioned in the native HA mode. If the customer is running HSRP or VRP on the downstream layer 3 switch, then basically, on the VeloCloud edges, for the static routes that is used to route to the local local LAN subnets, you would point the next hop at the virtual IP address of the HSRP or VRP of those switches. And if we're running routing protocol between the L3 downstream L3 switch and the VeloCloud edge, then at one time it's only the active edge device that is running the routing protocol that is pairing with the downstream devices. Okay. Next, we'll talk about VRP. So when with the insertion of the VeloCloud edge and the CE device, using VRP, so basically you would use a different interface so that the edge can establish overlay across that CE device to establish the overlay to MPLS. Then it would have an overlay across the internet, and then it would basically run VRP between the CE router and the edge device. And by default, you want to make sure that the VRP is actually, the VCE is actually the VRP master. And only when it goes down, that VRP would fail over to the CE. So by default, the VCE will actually advertise DHCP and set itself as the default gateway, or set the VRP VIP as the default gateway. And it can be configured on any routed port, sub-interface, or VLAN interfaces, or layer 3 SVIs. So what would happen when it goes down? It either goes down, or if it loses connectivity to the VCGs, right? If it loses the control plane to the VeloCloud gateways, it would actually reduce its VRP priority from whatever value you set it to 10, so that the standby, not the standby, sorry, the CE router would become the VRP master when it loses the connectivity towards the controller. And so what this basically implies is that, similar to this drawing here, if it's a hybrid site, basically, what you don't want is if we lose connectivity to the internet, which means we lose connection to the VeloCloud gateway. If you do not want if you don't want the CE to become the VRP master, then you would need to establish a control plane session across MPLS towards the VeloCloud gateway as well. So basically, there's an option on the overlay on the interface to mark the MPLS interface to be sd-wan reachable, which means that as long as the MPLS has internet breakout, then the VeloCloud edge here would also establish an overlay across the MPLS to the controller that sits on the internet as well. So that way, if the internet goes down at that site, as long as the edge can still reach the controller across MPLS, it would not reduce VRP priority down to 10, right? So in this case, let's look at the failover scenario. So if the edge completely goes down, then VRP master would be the CE router, and then traffic would just simply flow out this way. When it comes back, it will re-advertise its priority, right, that you set within the configurations. Hopefully it's higher than the CE router. Then traffic would go back through the edge device. There's one thing to note though, even in the last slide here, we drew the connectivity for the MPLS overlay tunnel across the LAN. This is actually this is not recommended. What I mean by that is basically you want a separate interface to establish the overlay across MPLS when you have this insertion topology. If you have to establish the overlay across MPLS, from the same routing interface towards that's running VRP, then you would have to use a different sub interface. What we typically recommend is just a different interface for like a transit VLAN, right? So it can be connected to the CE, and we would just establish overlay tunnel this way, and then the separate interface would be used to run VRP. And just again, using the same interface for both VRP and for establishing overlay across MPLS is not supported. The reason is that by default, a remote branch that learns the VRP prefix, we would that is also used for the overlay tunnel. A remote branch that learns that prefix would not redistribute it to another, to using routing protocol, for example. Next, we're going to discuss hub clustering. So, this is this slide basically describes how that actually works. So it's actually the controller that decide which hub a branch device should establish the overlay tunnel to. So when you configure multiple hubs in a cluster, each of the hubs will be talking to the controller and updating the controllers about its stats, right? CPU, memory, and number of tunnels, for example. And so note that in this hub clustering scenario, there is no state sync between the hub edge devices, and they also require individual IPs on each of the WAN and LAN interfaces. So they almost behave like independent devices, and the only thing that's aware of them being a cluster is really the VeloCloud gateway or the VeloCloud controller. And so, if you are placing, let's say, 2 hub devices in a cluster in a data center, note that you're going to need, 2 different public IP addresses, one for each of the hub devices, if you want the tunnels to be established across the internet. So when a branch needs to connect to a cluster, it first establish an overlay to the controller, and then from there, the controller will actually assign the branch edge device which of the hubs to connect to based on their load. And so if a hub actually fails, or if a hub actually crosses the utilization threshold, then the controller will assign the branch edge to talk to another hub device. Note that in this hub clustering design, right? If you have branch A that is connected to hub number 3, and branch B that is connected to hub number 4, and let's say you're routing a BGP between the hub device and the layer 3 switch, then without dynamic branch to branch, traffic going from A to B would have to traverse, basically hub 3, then to the core switch, then to hub number 4 and reach branch B. So just be careful that if you're running BGP there, and you use the same AS number, hub 4 needs to learn branch A prefix, right? So you would either, if you're using the same AS number, you would have to do allow AS. Typically, we would recommend eBGP just because it's easier to identify where the route was injected, and you don't have to worry about basically BGP revoking routes that has its own AS number in it. So just as a quick summary, right? This is designed with hub clustering, and this should only be used in the data center, and there should never really be a good reason to use this at a branch site. And so in this case, each of the hubs or hub VCEs in the cluster would run BGP with a core switch. They would have their own BGP sessions as well as their own public IP address to connect to establish overlay towards the internet. And they almost behave like independent devices, and the controller will decide which of the hub devices a branch should connect to. From a configuration standpoint, it's very easy. Just drag and drop, go to network services in the VCO, and you would simply move a specific hub device into a cluster that you create. And then when you assign it to a branch profile, it's just a very simple drag and drop, right? To assign a cluster to a branch profile, and then you would just drag that cluster to allow it to be either a backhaul hub cluster or used for branch-to-branch VPN initiation. So in the previous slide, once you allow that cluster to be configured as a backhaul hub cluster, then under business policies, you can actually very easily basically use that cluster for internet backhaul. So simply create a business policy to say any destination going to the internet, I want to go ahead and select the hub cluster, right, to backhaul the traffic to. Okay, the last section or few slides, we're going to discuss the integration of security with the SD-WAN solution, and most of this really involves around how to actually secure the internet-bound traffic. So there are three options. First one here is basically you configure a hub, a regional hub for the branches, and basically backhaul internet traffic towards the hubs, which can sit in a HQ, like a headquarters or a data center. And so all traffic would have to go through the hub, and in return, the firewall that sits at that that data center or HQ for traffic to be filtered. So in this case, you would disable split tunneling of all internet traffic, right, from the branch edge, and then configure internet backhaul towards the hubs so that the branch edge can use both internet and MPLS to backhaul the internet traffic to the regional hub. Second option is obviously to place a firewall downstream from the edge device at each of the branches. So when that traffic comes to the branch edge, it's already been approved and filtered by the firewall. In that case, you can choose choose to either send the internet traffic direct, right, out to the internet directly, or you can decide to basically optimize SAS traffic and send it to the VeloCloud gateway. The option on the right, which is like fairly common now with SD-WAN deployment is actually using a cloud web security solution. In this, for this design option, you would configure a web security solution such as Zscaler or Symantec as the backhaul hub, actually. So for certain traffic, you can decide to backhaul all internet traffic, for example, towards the web security solution, and then not allow any internet traffic, right, to go out direct. Or you can actually choose certain trusted SaaS applications like Salesforce, for example, to be sent through the VeloCloud gateway optionally, and then basically do a service insertion for all other internet-bound traffic. So that way, if there's traffic going through the internet from the local LAN, it would go multipath, from the VeloCloud edge towards the VeloCloud gateway, and then the VeloCloud gateway would then decrypt that traffic from the sd-wan tunnel, send it into the standard IPsec tunnel towards the cloud web security solution, and then that web security solution would then NAT the traffic towards the internet. And the reason the traffic has to traverse through the VeloCloud gateway in this case is because by default, the standard IPsec tunnels, which we use for insertion of the cloud web security solution, is actually established from the gateway. And starting in release 3.2, we will support tunnel initiation to Symantec, their cloud web security solution directly from the edge. And so those are really the three options. And for option number 2 here, we now support basically a Palo Alto firewall as VNF on the specific hardware platforms. So there are the two new platforms called 520V and 540V, where we can run a Palo Alto firewall on the edge as a VNF. The management of that firewall still goes through Panamera, I believe. Panamera. So essentially the Palo Alto firewall, Palo Alto's management interface. Sorry, it's called Panorama. Apologies. So licensing would still go through Palo Alto, and we're simply using running the Palo Alto firewall as a VNF. So comparing those three options, right, from manageability and performance standpoint. So obviously, having the VNF on the branch edge directly for internet-bound traffic is obviously the most optimized solution from a performance standpoint. But then again, you would have to manage those VNFs using a separate platform, right? So using the Palo Alto's management platform. For regional backhaul, it's very easy to manage, because all of the filtering will be done at the hub locations firewalls. And so, from a performance standpoint, you suffer a little bit because branch internet traffic would need to be backhauled through the data center or regional hubs, and you would have to increase the bandwidth at those regional hubs. So the cloud web security solution is sort of in the middle there, where you would still be able to use the VeloCloud gateways to optimize certain trusted SaaS applications or certain trusted internet-bound applications, but everything else that you choose to send through web security can then be backhauled towards the regional-based web security, cloud web security data centers. So here's a comparison between the different options. and then what is supported. So for IDS and IPS, that, if you're using the web-based security option, then that is obviously vendor specific. So technically, I just want to go over the three options here. So option, really, this is the second option in my previous slide, is where we place a Palo Alto VNF, at each of the branches, or when you place a Palo Alto firewall or any other firewall at each of the branch office. And again, this Palo Alto as a VNF on the VCE is only supported on the 520V and 540V platforms. Okay, so in this case, once the traffic is filtered, where the VNF is basically integrated on in a bridge mode, then when the traffic arrives on the VeloCloud edge, then it's already been filtered by the firewall, and therefore we can choose to send it either across overlays, send it underlay, unencrypted directly out towards the internet, and etc. For the cloud web security integration to secure internet-bound traffic, then basically there will be tunnels established from the edge to the VeloCloud gateway, and then the VeloCloud gateway would have separate IPsec tunnels to those web security cloud solutions. And then so internet-bound traffic will go from the LAN to the edge, then send multipath towards the gateway, then sent to the cloud security solution via standard IPsec tunnel, and then get natted out that way. With this solution, you can actually decide to optionally send trusted SaaS applications, like Office 365, directly out, right, from the gateway, instead of filtering through the cloud security solution. Okay, and the last option is basically backhauling. So if you have multiple regional hubs, right, in the topology, you can actually choose to backhaul internet traffic from a branch edge towards the regional hub that is designated for that profile, for the network profile. So in this case, traffic that is from a branch would have to go through the branch edge. The branch edge would then send it to the regional hub across all of the available tunnels that it can use to connect to that regional hub. And then the regional hub would have maybe a default route to send it out to the firewall at that location. So in this case, you would eliminate the need to have a firewall at the branch. So all traffic will need to be scrubbed, right, at the regional hub. And in the same sense, from a regional branch, from the branch, you can actually use business policy to send traffic directly to the gateway optionally, if your security team allows that. So that summarizes session here. So just some key takeaways, right? With VeloCloud SD-WAN or NSX SD-WAN, it offers a lot of different deployment options and give you a lot of flexibility in terms of architecture. We support various routing protocols and for underlay routing, and then for insertion topology, right? We pretty much right now can support all of the different branch insertion topologies. And then at last, we covered basically the different HA models, including the native HA model, VRP insertion, and as well as clustering at the data center. Right, thanks.